Are we cool? Everyone is basically comfortable? Yeah, I know. Maybe we should open another window out there. It's starting to feel like a sauna in here. Yeah, no worries. Sorry guys. Breathe slow. Observe that. Anyways, first of all, nice to meet you all. My name is Gil Rosenberg. I'm a product manager in Red Hat, specifically in charge of, basically under my domain is the OpenStack architecture. So if any of you are utilizing Red Hat OpenStack platform and you want someone to blame for the new changes that we've made, yeah, you can basically kick me afterwards. In addition to that, I'm also in charge of the OpenShift integrations, so basically OpenStack and OpenShift, and now basically OpenShift and OpenStack with the new architecture. And in addition to that, I'm also in charge on some of the new evolutions that we are bringing to the platform, basically new services. And that's what we cover today. Now, it's a short presentation. I don't really like slides, okay? I really like to have conversations in general. Then I have also a short demo, very short demo. But the idea here is that we can try to go through basically the core fundamentals of why we thought it is important to resurrect Watcher, okay? What we see basically in the landscape. When we're looking at, for example, the amazing gift that Broadcom gave us all. And yeah, but basically I would like to hear from you. If you have any past experience with Watcher, if that's something that you're looking to implement, if something that you're looking to contribute to, by all means. So, why? Why we kind of, resurrected Watcher? Watcher was introduced in 2016. I think the last commit that I've seen was late 2020 or something like that. But we are seeing a growing number of customers, like very large, major shift, maybe because of that last line here. We're looking for alternatives. For how we call them, legacy virtualization platforms, right? A lot of them are coming from VMware. I think it's a pretty well-known theme that I'm not sure that Broadcom anticipated, but hey, a gift is a gift. And those customers, which are traditionally enterprises and large ones at that, they have started to basically look at the possibility of adopting a platform like OpenStack for the traditional virtualization. But one of the keys which was basically missing is how they are going about optimizing the workloads in day two. Now, some of those have a lot of churn. So, when, for example, we're thinking about kind of the niche that OpenStack kind of settled into in the past decade, which is telco. The persona of the telco user is kind of very static almost. So we have the VNFs. The VNFs are tightly coupled in a lot of cases to the hardware that they're running, right? Tightly coupled to the infrastructure, not moving a lot. So placement, which is doing a pretty good job in day one, is, well, good enough for those use cases mostly. That's not the case when we're thinking about insurance companies, banks, even ISPs, which are selling their services to third parties. Those guys have a lot of churn. They have a lot of sub-use, a lot of tenants. And one of the key things that they want to preserve is the SLA that they want to basically give to those tenants. Now, in OpenStack, as we said, we know how to manage a very large virtualization cloud. We're doing a pretty good job in isolating those tenants, right? From a resource perspective. But in day two, we're doing a pretty good job to basically set those, or try to optimize the workload, so we'll avoid the congestions, we'll avoid the bottlenecks, the potential bottlenecks that such a large environment, high churn environment can basically give us. So how we should solve it, or how we should go about solving that? Okay, we collect metrics, right? We know basically where our workloads are running in day one, and we know that basically placement does a pretty good job with that. But what about the rest of the week, as we say? So we've decided to resurrect Watcher, and it gives us a few key benefits. It's not perfect, okay? Let's put it basically up front on the table. It's not perfect. Right now, we are basically taking it through a productization journey of sorts, and we're taking it quite seriously. For example, we've released the first tech preview of Watcher earlier in the year. So the first time our customers and partners, whomever is basically wants to kind of play around with Rosos on the architecture and OpenStack services on OpenShift, wanted to basically have a first look at Watcher, it was on March. So March 2025, we released the first dev preview of Watcher on what we are calling feature release still. So everything basically in the new architecture is carved using time-based releases. In those time-based releases, we are promoting not only bug fixes, not only basically enhancements for scale and stability, but also net new features. For example, net new services. Watcher is one of them. Okay, so we've introduced two tech previews. One, as we said, was in March. The second one was on June, July, so the end of June, which was basically the second phase of the tech preview, in which we've added more stability and we've introduced new strategies, okay, in Watcher. And we're gonna G8 finally, fingers crossed, at the end of November. So in the end of November, it will be basically fully supported. The main focus that we are looking to achieve with Watcher is first and foremost the basics. So we've taken the strategies that we already have in the Option Community project, and we kind of basically rigorously tested them and make sure that everything which relates to workload stability, this is basically shuffling around workloads to have them as stable as possible. Okay, mostly driven by specific metrics, mostly CPU and memory bound, okay, is working fairly well. The second functionality that we wanted to introduce, because it actually carries a lot of weight with our customers, is the ability to smartly evacuate a set of nodes for day to maintenance. So basically the evacuation strategy and then the consolidation strategies. So we have the consolidation strategy, that's one thing. The evacuation one also helps us a lot with updates and upgrades. So for example, if I need to, change disks, if I need to change faulty memory, if I need to evacuate nodes, okay, in general, okay, I can basically target some of those and initiate the audit for the what we're calling zone migration strategies. Now, it could mislead a bit. We're not talking about a zone as basically Nova looks at it, right, or any other of these services. A zone basically is something flexible in Watcher. It's the set of nodes that we currently want to target, which is pretty good because, well, evacuating an entire Nova zone is like, I don't know, painful. At least if you have like a time maintenance window to do that. But that's basically embedded right now as a service, or basically provided as a service in the platform without any extra automation externally. We don't need to orchestrate through heat. We can, if you're masochistic, you can try to do it with it as well. You can still do it with Ansible, but now you have actually an API endpoint and a structured way to kind of move those, or to kind of drain those nodes and reshuffle the workloads across the other nodes, so you can actually handle maintenance in a more predictive and, well, kind of straightforward way. And additionally, kind of building on the same foundation is also the consolidation of nodes. So, for example, the exact opposite, right, from hotspots in our infrastructure is or unutilized infrastructure. And we have another strategy for that, in which we can actually target, okay, our setup, basically target an infrastructure and say, okay, I have basically unused nodes, I have extra capacity in some other nodes, I can then go and evacuate those nodes and even shut them down or even kind of shelve them. I can then respin them back if I need to, but I'm saving costs by doing that. I'm saving the node's amortization and attrition, and I'm also saving power, right? And all of those basically are strategies that we can work with kind of ad hoc. And I'm saying ad hoc because one of the things that we are planning to invest in heavily in the upcoming cycle is to actually have the ability to layer those. So basically not having only one strategy running at a time, but actually creating an interaction point between different strategies. So for example, right, I can do a zone evacuation and a workload balancing, but in a certain way that will be smart enough so I won't get hotspots or congestions or timeouts when I'm trying to implement two strategies at the same time. The overall strategy of Watcher, it's kind of the high level. We have basically the decision engine. Decision engine is kind of the meat of the entire thing. Right? Basically, all of the metrics are flowing into it. Okay, the services are basically getting pinged and managed. Basically, when you need to shuffle those workloads around, basically balance everything. Those are basically being driven by the decision engine and the execution, the apply. Okay, those two main components, okay, the applier and the decision engines, are our key focus when we're trying to enhance the Watcher. If you ask me, my end goal, maybe I'm a bit megalomaniac when I'm thinking about it, but my main goal with this one is to actually create a tiering system, like a real fully fledged tiering system in OpenStack, which will enable us to actually provide, it will never be rigid, but best effort SLAs to the tenants, or at least to the cloud admin. If we can achieve that, and that's basically the goal I'm trying to put, basically to strive to in the company, but also with our engineers, amazing engineers that are working with the community, is to try to get to that specific target. And if we can achieve that, that basically gives us like almost, I wouldn't be, as you said, too presumptuous to saying Amazon-like tiering systems within our on-prem cloud, but something which kind of gets close to, or at least try to mimic that, and that's like real still value for our customers. At least those who like really have that low, that high churn, that high volume of workloads that they want to run and need to run. The way that we are going about interacting with Watcher is basically with all of the OpenStack services. We can do that through the UI, we can do it through the CLI, through the API endpoints. The idea here is basically that for my optimization strategies, as we are calling them, we are creating an audit template. Okay, that one basically takes into account the specific metrics. Okay, I'm sorry, that we want to employ. Okay, we can employ multiple metrics. One of the things that we're working on from the decision engine point of view is to actually create those weighted functionalities to strategies who are creating different, or basically are carrying different metrics endpoints. So for example, one of the key aspects that our individual, also customers told us that they want to actually look at is not only to always lead right with CPU and memory-driven metrics as the sole priority. Okay, for example, if we're deploying distributed systems, and a lot of our customers are deploying distributed systems on top of OpenStack because it's a cloud, eventually. One of the key things that we want to actually look at and probe and make sure is always optimized, or at least as optimized as we can get it, is network latency in this guy. Those are key tenets of a well-balanced distributed system, right? And that's something, for example, that I, in some cases, would like to prioritize even over CPU consumption. By the way, in a lot of cases, this pressure can cause CPU hangouts, can cause basically lockouts. So that's basically some of the enhancements that we're trying to look and to introduce into the Watcher apply and decision engine as we go along. But this is what you're seeing in the slide behind me is kind of how we take all the steps that kind of we're taking to create that specific functionality, that specific strategy, and apply it to my running infrastructure. Want to see a quick demo?
Yeah.
So, small one, okay? I'm actually working on something a bit more bigger in my environment, but it's a bit flaky right now. So we have something which I know it works, so we'll get the look and feel of how the thing actually works.
This demo shows how a Red Hat Services on OpenShift roster administrator might use the optimized service workload balance migration strategy to move a workload whenever a host's CPU or RAM utilization percentage is higher than a specified threshold. To run this demo, we have set up an operational roster 18 in which the optimized service is running, and 2 compute nodes with instances all running on one of the nodes. We are logged into the OpenStack dashboard horizon as a user with OpenStack admin privileges. The admin menu is enabled by selecting the project where you have the admin role assigned. The optimization menu is available here. We are going to create a new audit template. With the goal of workload balancing and the strategy of workload stabilization.
Thank you. What the hell happened to me? Why is that moving back? I'm not sure. Here we go.
This demo shows workload whenever a host in which the optimized service is run. Stack dashboard horizon. The session menu is available here.
Who says you can fuck up a recorded demo?
With the goal of workload balancing and the strategy of workload stabilization. With this new audit template, we are now going to create an audit. The audit will be continuous with an interval of 180 seconds. If we click the UUID of the audit, we can see the action plans that are created for this audit. Because the instances created with a simple workflow have low resource usage, the initial plan does not contain any realistic actions. We are now going to increase the CPU consumption of one of the created instances. After a few minutes, the CPU usage of the edited instance should increase up to close to 100%. We see that now execution of the audit has generated a non-empty action plan with a recommended status. The recommended plan has now a migrate action. And the migrate action has a resource name that matches the node where we increased the load. We now start the action for the recommended action plan. And we can track this action plan until it is succeeded. Check the distribution of the test instances over the hosts. And we see that the host where the instance where the load was increased has moved to a new host. We can now start the continuous audit using the command line if we wish. This is showing a workflow of the optimized service through the UI.
Cool. Nice cyborgy voice for you. Speaking about cyborg, you know what comes simulator if you want something interesting about cyborg. Okay. Any questions?
I have a question.
Shoot.
You put that it's continuously watching, like testing every 3 minutes.
Yeah.
What happens if I have a VM that has a periodic load, like it loads every 3 minutes?
So first of all,
Do I get like
those are tunables. We just chose like 180 seconds. You can do it in every 15 or something like that. But the idea here is to, first of all, allow Prometheus to gather enough metrics, okay, and have to allow the decision engine to actually query those. So he will basically to create some sort of a pattern. Now, when you're actually using the thing, in some cases you will get, for example, the first action plan. But one of the things that, at least I observe when I tested in my lab, that if you're going to wait, for example, another couple of minutes, it will start to look at a broader and broader picture because it gets more and more metrics. And then, for example, it will start to see whether it can potentially move other VMs. Because one of the things, so when you have like a fairly large VM, which is kind of bombarding the metric, okay, it's kind of like a noisy neighbor, right? And now the decision basically is whether you are moving that noisy neighbor, right? Or you are starting to evacuate other workloads, which might be a little bit easier to migrate. They have less RAM, okay? They're less busy. So that's kind of also something which takes into account and is basically give the system some time to actually learn. It's not a one-time thing. It's not a one-time spike, right? Then it will get a better decision for you.
My question is more like, if the VM is generating load every 5 minutes, I'm watching every 3 minutes or 5 minutes, do I get 100 lines that say migrate, or
for
by the time
example,
I look into this, it's already gone, that load?
Yeah, but one of the things that you will always be prompted to do is the last action plan. So yes, you will see basically multiple of those. You will see, for example, recommendations to move, 20-25% of your workloads. But for example, once the next batch of kind of spikes will hit, and it will see a better picture of the overall infrastructure, okay, that specific recommendation will be cancelled, you'll get a new one. Okay, and yeah, we can track those. It's like this, it's not like the most, I would say, can basically expose your your UI in some point in time. So you should periodically, or we should periodically try to clean those, at least the ones who are not relevant anymore. Okay, because for example, if you're running that continuous audit, you will see all the track, all the audits, for example, which are empty. And that basically, I'm not sure that it's being cleaned. I need to check that, by the way. But yeah, we need to clean it. Right now, as far as I've seen, it's manual clean, which is not ideal. Simon!
Yeah. So all of those action plans are currently manually invoked. Is there a way that we can force them to be automatically invoked after a period of time or something like that?
Yeah, so we have the ability to schedule them, okay? It's not perfect. Basically, it's a counter from one to the other, okay? Similar to basically what we have seen. If I remember correctly, we can inject the intervals. So for example, activate a one-shot strategy, okay, a one-shot action plan every other weekend or every weekend. Or for example, in a specific period in the year, say Black Friday, okay, whatever. Execute a continuous one and kill it after n. Basically after a number of cycles, after I think a number of minutes, if I remember correctly. Again, that's actually something that is available. It's not that well. It's a bit coarse. Something that we are looking to improve. Actually, good point. Thank you for that.
Are there any plans to contribute it back upstream so it can be used outside of OpenShift, or is?
Sorry again.
Yeah. Are there any plans to contribute it back upstream so it can be used outside of OpenShift?
So the thing around here. So first of all, thank you for the question. That's actually a very good one. The way that we are packaging those services is to Go operators.
Yep.
Okay. So technically, if you have the ability to run a Go operator in one way, shape, or form, you can consume it. Okay. I'm not sure if the presentations would be shared with you. Hopefully they will. But putting in one of them. Over here. Go back. God damn it. So over here, there's a link to the Git. Okay, so you can actually basically, consume that. If you have the dependencies, basically to create the Go operator itself and run it. Okay, you could basically test some of that code. But the current plan, because we want to move fast, because as we said, we actually have customers waiting for it. Like over here. By my neck. We are prototyping as quickly as we can.
Yeah.
So I know it's not the perfect approach, but it is working out. Yes, Mr.
Yeah, so just to clarify that, the core Watcher functionality is all totally upstream, right? Because Red Hat always does upstream first. It's only the Go operators that are wrapping that.
Exactly.
They're also upstream, they're just outside of OpenDev, right?
Yep.
They're in a different OpenStack K8S operators community.
So basically the Git is referring to the packaging, referring to the wrappers, referring to kind of the payload code is the upstream Watcher, the one that we are contributing to based on the upstream cycles. But if you want to consume it as kind of as roughly as we are, you can actually clone the Git and work with it. Yes.
So the load can actually be distributed across. Let's say if I want to keep having my load can be weekly. I might have more load on the weekends versus less load on the weekdays.
So you can actually trigger different strategies in different time points.
Okay.
So for example, one of the things that makes sense to do like a one-shot is the workload consolidation. So say for example at the weekends, right, you kind of have a breather or something like that. A lot of your infrastructure is currently unutilized. You can run a one-shot consolidation strategy, release some of those nodes, reduce the power consumption. I don't know, if you're really into it, really shut them down and just don't forget to put them back up on Monday. But you can do that. And then the workload balance would actually rebalance the workload after that, because the nodes which are currently available currently active. Yeah.
on the whole Broadcom topic, one of the main complaints we get also from the VMware users like, oh, but the VMware auto recovers my failed VM. Does Watcher also can have an automatic trigger to, well, when a hypervisor goes down, it actually like takes care of the load that has been running on the hypervisor and moves it to another one?
So we have instance AJ for that, which could be applied. So it doesn't specifically ties into Watcher. Basically what you're saying is you want a fault tolerance swapping, something of that sort. That's interesting.
In VMware it's HA cluster and this is DRS. Right?
Yeah.
Different things.
There's an OpenStack.
But what he said, we have the two capabilities. It is interesting to see if we can kind of bring them together.
I have a question actually. So your recommendations are based on CPU, memory and network, or network not at the moment?
Actually, we have quite a long metrics. The big ones are, so the big ones which are currently referring to are CPU and memory utilization, but you also have disk pressure, you also have I/O latency. Because we moved to a Prometheus-based backend for the metrics, it kind of basically creates a lot of opportunity for us to kind of consume metrics and act on those.
So, and in terms of memory, how do you measure it, or what is the algorithm? Because it's very tricky, the memory in the guest operating system and from the hypervisor. So how do you?
Actually, the details themselves, I don't know them, I have to say.
Unfortunately, I know all details of the solution. They are working on it for 15 plus years.
Some of them are basically being collected through libvirt. Some of them are related to one of the things I think is a bit tricky is when you're running huge pages, and that could create a bit of a turmoil when it comes to how exactly you're measuring utilization. But the actual algorithm, I need to look into.
Because memory usage from hypervisor perspective is totally different than memory usage from
the host
operating system. There are empty pages and all this stuff.
So, are there any plans to also extend this to Cinder? Like, for instance, the same thing can actually happen, as you said, talk about iOS and all, right? The IOPS and everything as well. Those are also important metrics for the VM and the storage to work together. So, is there something that we can see this actually kind of does the migration of the Cinder volumes depending on the storage load or storage?
Not yet, but that's something we're looking at.
If you're using a shared backend, that's going to be a completely different response. They're not going to necessarily have the information from that unless that backend is aware of the information to previous.
But we don't have a Cinder mandate APIs that
Any other questions? What's your lunch?